For perfect problem 1 for Math 243. We're asked to do a bunch of stuff, kind of the same stuff you'll be asked to do on this week's quiz, for some data. Although in this specific problem I don't tell you the data, I give you a stem and leaf plot down here, which has all the data in it. Okay, the stem and leaf plot is something. It's the time that it took dogs to finish an obstacle course, whatever. I want you to sketch a histogram starting at 60 with bins of length 10. I'm going to make a histogram. I'm going to use my calculator to do it. You can do them by hand. The way I'm going to use my calculator is I first have to tell it all this data. So I got to understand what all this means. This 4 right here means an observation of 64. This 0 is an observation of 70. This 2 is an observation of 72. There's another 72, 75, 77, and so on. So the first thing is understanding what your stem and leaf plot tells you. Your second thing is putting that into your calculator. So we'll hit Stat and then Edit. I already have some data in L1. I'm just going to go ahead and clear that out so I can reuse L1. My first observation is 64. My second one is 70. Third one is 72, and so on. Rather than type all those in while you watch, I'll pause this video and type them in. Alright, I've gotten all those observations in there. It says there's 20 randomly selected dogs. I typed them in, it asked me for my 21st observation. That's good. That means I got 20 in there. It looks like I didn't screw anything up. Hopefully. Now I got it in there, so let's start doing some work. Part 1 says sketch a histogram. Okay, the way I sketch a histogram is under stat plots. Second y equals. Go into stat plots, turn your plot on, select the type that looks like a histogram, tell it what list your data's in, mine's in L1, leave the frequency as 1, and then hit window. You hit window, you want to tell it your minimum value, which is given to me to be 60. Your maximum value, well, let's see, it goes all the way up to 145, so I want some number bigger than 145, maybe 150. Plenty. You can do more if you wanted. Your scale, this is your bin size here. In this case, it says to use a bin size of 8. And then your minimum, I'll leave a -1 in there. I just like to have a little border. Your maximum just means what's the most observations you're going to have in any given bin. Hard to know at this point. Just give it some number big enough so that you don't have more than that. I'll say 8. And then take a look, hit graph. See how it turned out. There we go, looks like a histogram. Draw that thing. It might help to draw it, to use this trace button. So I got my axis here. Since I start at 60, what some people do is they put a little squiggly line here to kind of show that really on the number line 60 wouldn't be right here. Whatever. And then I count up by 8s. So I got from 60, 68, 76, 84, 92, 100, 108. Now, keep doing this until you get big enough for a bin for 145, 116, 124, 132, 140, 148. That'll work. And then you can go over here and say, all right, from 60 to 68, I had 1 observation. So I'll make the height just 1 here. From 68 to 76, I had 4 observations. 1, 2, 3, 4. What happened there? 60 to 68. Shoot, I screwed up is what happened. My first one was 60 to 68, so it should go this way. That had 1. And then from 68 to 76, I had 4. And then continue in that fashion. Then I got 6, 4, 1. There's 6. There's 4. There's 1, approximately speaking. Then I got 1, 1, 0, 1. 1, 1, 0, 1, and then 0, 1. Bam, there's a histogram. Good enough. Sketch a histogram. Yeah, looks like I did all that. Comment on the shape of the data. Alright, It looks skewed to me. It looks like it's skewed to the right. Maybe I'll say note, tail, pointing, right. Most of my observations are over here on the left-hand side. Some of them go way out to the right. Okay. Part 3, maybe it's time to switch colors. Calculate a bunch of stuff, a bunch of one variable statistics. Calculate mean, median, mode, or modes, and then comment on which is the most appropriate to use. What's nice is that your calculator does a lot of this for you. Hit the stat button, then over to calculate, and do one variable statistics. I want one variable statistics on L1, so I'll type in L1. If you don't type in L1, it defaults to L1 anyways. And it gives you some info. It tells you the mean. It's this X bar guy, given to me in this problem as 88. Median gives you that also. It's kind of hiding down at the bottom. There it is, 82.5. Note that the mean is significantly bigger than the median. That's something you would expect in right-skewed data. The mode is just which observation shows up the most. Well, 72 showed up twice, but 85 shows up twice also. So what do? Do you average those or something? Nope, you don't. You report them both. The modes are 72 and 85. We say it's bimodal, and those are the two modes. Whatever, mode's not that important. Which is the most appropriate? Because it's skewed, we'll use median. When it's skewed, use median. When it's not skewed, use mean. Never use mode. Mode is stupid. Moving on to number 4. Calculate the range and the standard deviation of the sample data. All right, is that all I said? Range and standard deviation? All right, sure. Range. The way you calculate the range is it's your largest observation minus your smallest observation. Those are given to you in your calculator, or you can just look up in your data. My largest was 145. My smallest is 64. And so maximum and minimum. So if you do 145 minus 64, you can type it into your calculator if you want, or you could just do it and get 81. That's the range. What about, what's the other one? Standard deviation? Standard deviation. We've got a symbol for that. It's the letter S. Your calculator does S with an X next to it to emphasize we're talking about our data point that they calls X's. Fine. There it is. 20.316 maybe. I don't know how many decimal places you want to show. I'm just going to say 20.3. I'll show one decimal place. Fine. Round it however the hell you want. I don't care. Range, standard deviation. Think that's good? And then finally, part 5. Suppose you were told that the amount of time it takes all dogs in the population to complete this obstacle course is approximately normally distributed. Really? That's weird. My sample doesn't look normally distributed. That's okay. It's telling me that it is. Sample was just weird. You happen to pick a bunch of slow dogs by dumb luck. That happens sometimes. The population is approximately normally distributed. The mean is 80 and the standard deviation is 10. So I'm going to go down here. I'm going to say my mean is 80 and my standard deviation is 10. What my empirical rule tells me is that, well, let's see what it's asking. My empirical rule tells me a lot of stuff. What percentage of the population would you expect to finish the course in less than 1 minute? 1 minute is 60 seconds. It's the first thing you need to know. Fairly confident everybody knows that. So one standard deviation below 80 would get me down to 70, and one above would get me up to 90. It's 2 standard deviations that I'd have to go to get down to 60 here. So what my empirical rule tells me, well, it actually tells me a lot of stuff. One of the things my empirical rule tells me is that 95% of the data falls within 2 standard deviations of the mean. In other words, this shaded region in here constitutes 95% of the distribution. Damn near all of it, but not all of it. What that means, if 95% is in the middle, That means there's a total of 5% in these two tails, right? I got to get 100% somewhere. And because this distribution is symmetric, that tells me there's the same amount down here as there is up here. So I got 95% in the middle. That means 5% is on the outsides. If there's 5% on the outsides and there's two outsides for that 5% to be in, that means there must be 2.5% on this side and 2.5% on this side. This picture answers my question because my question said, what percentage of the population would you expect to finish the course in less than 1 minute? Come down and look at the picture. Less than 1 minute here looks like 2.5%. I'd expect 2.5% to finish in less than 60 seconds, 1 minute. And that's because of this 2.5 right here. 2.5% down here, that means I'd expect 2.5% to finish in less than 1 minute. That's the answer to part 5. I think that's the last thing we had to do, right? Explain? Yeah, I guess I explained. I didn't know if I explained by writing it, but I at least talked a lot, which I think I'm going to call that good enough and end this video here.